In the quiet void of space, where the stars twinkle like distant beacons of light, a more elusive phenomenon travels through the cosmos, unseen by the naked eye. These are cosmic rays, particles so small, yet so incredibly powerful. They are the universe's way of sending us messages from the farthest reaches of space and time. For more than a century, we have been captivated by the mystery of these high-energy particles. Where do they come from? What cosmic forces are at play to propel them across the universe? We know they are born in the most violent of cosmic events. Yet despite our best efforts, the true origins of these cosmic messengers remain a puzzle scattered across the heavens. And yet, cosmic rays are not just a curiosity. They are clues, keys to unlocking the universe's most powerful and extreme processes. These particles, which carry the echoes of supernovae, the pulses of black holes, and the remnants of ancient stars, have traveled billions of light years to reach us. They carry within them stories of cosmic destruction, creation, and rebirth, stories of the universe itself. At their core, cosmic rays are simple, high-energy particles, mostly protons, along with a mix of atomic nuclei, traveling at nearly the speed of light, cutting through space like the ghostly remnants of a cosmic symphony. These tiny particles, seemingly insignificant, hold within them the power of the universe itself. When cosmic rays strike our atmosphere, they release a cascade of secondary particles, producing what we call air showers. These showers help us detect cosmic rays on Earth. But the true significance of these particles is not merely their arrival on our planet. It is the journey they have undertaken, an interstellar pilgrimage, crossing galaxies, hurtling through nebulae, and surviving the ravages of space-time itself. Their existence is not accidental. These particles are born of cosmic violence, the sudden implosions of massive stars, the heart-pounding churning of black holes, and the eruption of powerful supernovae. In their voyage across the universe, they are forged in the most extreme environments we know. Their energies, so vast, are beyond human comprehension. The energy of some cosmic rays far exceeds anything that we can achieve here on Earth. And in these particles, we find the raw power that governs the cosmos. Imagine, if you will, the journey of a single cosmic ray. It begins not as a mere speck of matter, but as the product of a cataclysmic event, a supernova explosion, or perhaps the deadly embrace of a black hole, pulling everything in its wake. From this moment of origin, it is launched into the cosmic abyss, on a journey that may span millions, even billions of years. Through space it travels unfathomable distances. The vastness of the universe becomes a mere backdrop as these particles, unstoppable and relentless, break through the fabric of space. But their path is far from straight. They are shaped by the very forces they encounter along the way: intergalactic magnetic fields, charged particles, and the gravity of faraway stars and galaxies. For every cosmic ray that arrives at Earth, countless others are deflected or altered, their journeys twisted and bent. Yet, even in their unpredictability, cosmic rays remain a message, one that transcends the limits of space and time. They are not just particles, they are whispers from the cosmos, beckoning us to understand the forces that shape our universe. So, where do these cosmic messengers originate? The possibilities are as vast and mysterious as the cosmos itself. Take, for example, supernovae, the explosive deaths of massive stars. When a star reaches the end of its life, it collapses under its own gravity, exploding outward in a flash of brilliance, scattering the remains of the star into space. In these moments of destruction, Immense shock waves rip through space, accelerating particles to immense speeds that can turn a single proton into a cosmic ray. Or consider the supermassive black holes at the centers of galaxies. These cosmic giants are like cosmic engines, pulling everything into their gravitational well. As matter spirals toward the event horizon, it is crushed and heated to unimaginable temperatures, releasing jets of high-energy particles, cosmic rays that are blasted across the universe. Then, there are the gamma-ray bursts, the most energetic events in the universe. These bursts of energy are thought to occur when massive stars collapse or when neutron stars collide, creating explosions so powerful they can outshine entire galaxies. These bursts are the stuff of legends, events that stretch the limits of human imagination, and they may very well be responsible for some of the most energetic cosmic rays we observe. Tracking the origins of cosmic rays is not as simple as pointing a telescope and watching them fly by. The cosmic journey these particles undertake is anything but direct. As they move across the vastness of space, they encounter magnetic fields, the invisible webs that stretch between galaxies and stars. These fields twist and bend the paths of cosmic rays, making it almost impossible for us to trace them back to their exact point of origin. It's like trying to track the path of a comet through a thick fog. The trail may be clear at first, but the further it travels, the more obscured it becomes. Magnetic deflections create a veil of uncertainty, one that has confounded scientists for years. We can detect their energy, their arrival, their interaction with Earth's atmosphere, but tracing them back to the very stars or black holes that gave them life remains elusive. Why is this so challenging? Because the universe is not a place of stillness. It is a chaotic, dynamic tapestry of forces, constantly shifting, pulling, and twisting. As cosmic rays move through space, they encounter the galactic magnetic fields that stretch across the expanse between stars. These fields warp the paths of the cosmic rays, like currents in an invisible ocean. The magnetic fields of the Milky Way and other galaxies work like cosmic traffic cops, redirecting and distorting the paths of these energetic particles. Once cosmic rays have been bent and altered by these fields, they no longer carry a direct link to their point of origin. They become cosmic travelers, each one a mystery of the universe's most extreme environments. But there is one question that towers above all the others. What causes the highest energy cosmic rays? These particles, with energies far exceeding anything we can produce in our laboratories, challenge our understanding of physics itself. How can they achieve such energy? What cosmic forces are at work to create particles so powerful they defy our comprehension? Some of these extreme cosmic rays are thought to come from the most violent and energetic phenomena known to science. Gamma-ray bursts, active galactic nuclei, or even the collision of black holes, events that warp space-time itself, accelerating particles to unimaginable speeds. These are the birthplaces of the highest energy cosmic rays, and they are our final frontier in the search for answers. In 2017, the discovery of a high-energy neutrino by the IceCube Neutrino Observatory opened a new door. This neutrino, thought to have originated from a distant galaxy, may have provided the missing link between cosmic rays and their ultimate sources. It's a discovery that could rewrite the rules of astrophysics, linking high-energy particles to some of the universe's most extreme events. As we look to the future, we know that the journey to uncover the sources of cosmic rays has only just begun. The Pierre Auger Observatory, the Telescope Array, and the upcoming Cherenkov Telescope Array are all instruments that are pushing the boundaries of our knowledge. With each new observation, we come closer to understanding the forces that give birth to these particles and the incredible events that shape them. One of the greatest questions science faces today is not just how cosmic rays travel, but how they shape the universe. Could they play a role in the formation of stars, galaxies, and black holes? What role do they play in the very fabric of the cosmos? As we unravel the mysteries of cosmic rays, we are uncovering the interconnectedness of the universe itself. Cosmic rays are not just particles. They are beacons of energy, carrying the stories of the universe across unimaginable distances. They are the whispers of the cosmos, a message sent from distant stars and exploding supernovae, from black holes and gamma-ray bursts. They are the universe's way of speaking to us, offering clues about the processes that shape everything we know.